All right, let's talk about a really big shift in how we're building AI. We're moving way beyond simple chatbots. We're now trying to create systems that can actually reason, plan, and tackle complex problems with multiple steps. So, let's dive right in.
The real world is messy, right? Things rarely just go in a straight line. So what happens when an AI agent needs to try something, check its work, and then maybe try again? Or what if it has to pick between a few different tools depending on what's happening? That's the core problem we're going to unpack today.
So, on the left here, you can see the classic AI workflow. It's kind of like a conveyor belt. You put an input in one end, it goes through a couple of fixed steps, and an output pops out the other side. It's predictable for sure, but it's also super rigid. But on the right, that's where we're headed, a dynamic graph. It looks a lot more like a brain, doesn't it? It has loops for rethinking and branches for making choices. That flexibility is absolutely essential for dealing with any real complexity.
So how do we build these AI brains? Well, that's where a tool called LangGraph comes into the picture. It's basically an add-on to a framework you might have heard of, and it's designed specifically to build these dynamic, graph-based AIs we're talking about.
Okay, so what is LangGraph really? It's a library that works with LangChain, and its whole reason for being is to let developers build AI workflows as graphs instead of simple chains. That structure is what gives an agent the power to loop, to make choices, and maybe most importantly, to keep track of its own memory or state as it works through a problem.
This table really just lays it all out, doesn't it? It shows the upgrade perfectly. With the old chains, you're pretty much stuck on that straight conveyor belt, but LangGraph, that gives us a completely different, graph-based flow. I mean, look at the key differences. It's got built-in support for loops, way better memory management, and, this is a big one, the ability to pause and get a human's opinion. This isn't just a small tweak. It's really the foundation for building serious production-ready AI agents.
To really get how LangGraph pulls this off, we've got to look under the hood at its three main parts, what they call state, nodes, and edges.
First up, we've got the state. The easiest way to think about this is as the AI's short-term memory. It's like a scratch pad. It's this one central place that holds all the important info for the task, the original question, anything it's found along the way, you name it. And every single part of the graph can read from it and write to it.
Okay, so if the state is the memory, the nodes are the actions. These are the doers. Each node is a specific job or a step in the process. A node's job might be to call a language model, or maybe to search the web, or to analyze some piece of data. They're basically the individual steps of thinking the AI takes.
And finally, you have the edges. The edges are what connect all those nodes together. They're the pathways that guide the AI's train of thought, making the decisions about what to do next. An edge can be really simple, like, after A, you always do B. Or it can be a whole lot smarter.
And this is where the real magic is. There's a special kind of edge, a conditional one, that can actually look at the AI's memory, that state, and decide where to go next based on what it finds. So, did that web search actually work? If not, the edge can route the flow to a try again node. Does the AI think the answer is good enough? Then the edge can send it to the finish node. This lets the whole graph change its path as it goes.
Okay, so theory is one thing, but let's make this real. We're going to walk through a super simple Q&A agent just to see how all these pieces, the state, the nodes, the edges, all come together. The agent's mission is pretty clear. It gets a question from a user, and its job is to figure out, hey, can I answer this with what I already know, or do I need to hit the web and find some fresh information before I give an answer? So here's the agent's basic game plan. It starts and then immediately hits this decision point. It has to analyze the question and decide, do I need more info or am I good to go? Based on that decision, it either takes a little detour to do a search or it goes straight to putting the answer together. That branching path is the whole idea in action. So let's start it up. A user asks a question that definitely needs up-to-the-minute information, like the current stock price of Apple. That question becomes the very first thing written down on the agent's scratchpad. It's the initial state. Now, the first node in our graph, the Analyze node, kicks into gear. Its one and only job is to look at the question in the state and make a call. And here, it does its job perfectly. It realizes a web search is necessary, so it updates the state. It basically just flips a switch, setting a little flag that says, "Needs search is now true."
And because that flag is set to true, our special conditional edge knows exactly what to do. It reads the state and immediately routes the workflow over to the search node. That node then does its thing, runs a web search, and, this is key, it adds the results it found right back into that shared state. And from there, a simple edge just points the flow to the final stop, the answer node. And since this node can read the entire state, it sees both the original question and the brand new search results. It uses both pieces of info to put together a good, complete answer, adds that to the state, and just like that, the job is done.
That was a pretty basic example, but hopefully you see the logic. Now let's just quickly run through the real superpowers that this graph-based way of thinking unlocks.
First up is loops, or cycles. Because the graph can send the flow from a later step back to an earlier one, an agent can iterate. It can, say, write a first draft of an email, then have another node check it for tone. And if it's not right, it can loop back to the writing node to try again. It can keep doing this until the work is perfect.
Next is human review, and for building safe AI, this is absolutely crucial. LangGraph is built in breakpoints. You can program the agent to just stop at a critical moment, like right before it's about to delete a file, and just wait for a person to say, yep, that looks good, go ahead. It's an essential safety net.
And finally, persistence. LangGraph can save the entire state of a workflow at any point. This is called checkpointing. Think of it like a save button in a video game. It means a huge, long-running task can be paused and picked up right where it left off later, even if the whole system shuts down. It also lets you have these really long, ongoing conversations with an agent that remembers everything from before.
So let's zoom out. Why does this whole shift from a straight line to a dynamic graph actually matter so much? What's the big deal?
Well, when you boil it all down, this graph-based approach lets us build AI that is just smarter. It's more reliable. It's more aware of what it's doing. And when things go wrong, it's way easier to figure out why. We can finally move past these simple prompt and response bots and start creating agents that can carry out complex plans. This cyclical, state-aware model, it really is the key to building the next wave of AI that you can actually use for serious work.
And that really brings us to the big question, doesn't it? When we have tools that let an AI think in loops, to reflect on its own work, to try again, and even ask for help, the kinds of problems we can ask it to solve just explode. It's not just about answering questions anymore, it's about actually achieving goals. So what are we ready to solve next? That's something to think about. Thanks for watching.